Sure, please.
제가 제일 궁금한 거는 원천 기술 프로토콜을 개발하셨다고 얘기를 들었어요. 근데 그 말하는 프로토콜을 좀 쉽게 설명할 수 있겠습니까?
So I've heard about 토다프로토콜, which is the basis of all your programs and projects. What is it, and how can you explain to us easy way?
Sure. The internet today has the ability to transmit information, but information as it's being transmitted can be sent, yet another copy can be kept and sent to some other people. Yet and the receiver can make many copies of the information. And that's by design, works very well for information. If you were to send something of value, the current internet doesn't allow you to send value on the internet without having to depend on a third party, which was the plan to be addressed by what's so-called the blockchain using a ledger. But the ledger itself is replicated into all of those devices. How about we have a model that the network packets, as they're being transmitted from one person to the next, let's imagine each and every network packet has a unique number, and it can only belong to a single signing device in any block of time.
Okay.
Yeah.
With that definition, you can have anything of value represented on those packets.
그럼 이를테면 과거에 존재했던 백넷과 IPX, 노벨 네트워크,
Right.
they have their own protocols. Will
Right.
it be similar to your protocols?
Which protocol?
백넷, Ethernet,
The Ethernet, like
IEEE
yes,
802 dot what?
yes,
Internet, Ethernet,
yes. No, it's not. It cannot transmit value or manage value. It's good for information, but not for value. It doesn't give you unique representation of value in any packet. So here's the thing. If you have the ability to have this value, but yet you still have a centralized entity to control it, defeats the whole purpose.
Yeah.
Why? Because that centralized entity needs to be administered, and then you have to have another administrator, then you have to have an auditor, another auditor, manager on the auditors, and all of that ends up creating a lot of friction. If we figure out a way to not have any intermediary, have all the machines same class, then we're good to go. Then we are presenting something that can be peer-to-peer, and that's what is being presented here.
Everybody entity is that means every entity is connected networks entity is a server or client.
There is no server, there is no client. Everybody same class with Toda.
It's not different. The centralized not computing. This is point to point.
All devices are in the same class. There is no layers of servers, cloud.
Which is management function this networks.
Each and every device is responsible in every block of time for pseudo-random selection of packets into the network.
If it is full enough committed well performance, they have own address architecture. That overhead is very long or small. You have another architecture.
Think of this. Each and every device today is capable of receiving and sending millions of packets per second, the TCP packet. Now,
no IP based.
right. I'm talking about the actual. If you have we're having a video chat, we can have millions of packets being sent back and forth per second. I can be in New York, you can be in Seoul, we can have a video chat, millions of packets that go back and forth.
Yes.
That's what the capability of this device. Now imagine part of the processing this device is doing is calculating what it needs to do in every block of time. In this minute, there's a pseudo-random function. Pseudo-random means it's deterministic, based on its signing capability, which is the address of the...
Everybody network have their own handshaking protocols.
Right.
So right.
HTTP
looks like...
Right, but but this is not HTTP.
It's not handshaking protocol.
We didn't get to the handshake. So each and every device knows how to look at its own number and the previous block hash. For now, just think with me. The block hash, think of that as 32 characters.
Typical.
Okay? 32 characters. Which is a typical cryptographic hash. Or 256 zeros and ones. Okay? By putting the two together, a simple mathematical function can give you in each and every block of time which packets your device can work on in this block of time. So let's say in this block of time you have 8 packets. Each and every device has, let's say, 8 packets to take care of. What does it do in those 8 packets? There's something that is called deterministic distributed computing, which means it takes each and every packet and it couples it with another packet, and it does that work all the way through something that is called the Merkle tree, but here it's a deterministic Merkle tree. So each and every device contributes to the creation of that Merkle tree, which means each and every device arrives to the top of that tree at the same time, and that's the Merkle root. And it does it again and again and again. So there's one replicated truth in every block of time, which is the root. Now, for the average user, what does it mean? As an average user, if you have something of value, if you send me something of value, let's say you send me an ownership of a car or a piece of land or $5, I receive that. You send it to me. The rest of the network, they're not concerned about this, they're concerned about the hash. You hash it, that transaction, I know what's in it, I hash it as well, and together we look to send it to those packets, to those up to 32 devices that could be responsible of those packets, which means those are going to do the work. Any one of them can do the work. It requires only one to do the work, but it's up to 32 because you need to have redundancy. So from the average user perspective, you can send me that packet, I receive it, I know that I can keep it and not be accessing the network. It can be off the network, it can come back anytime. Anytime from this moment onwards into the future, I have the proof in my device that I've received the ownership of those packets and no one else owns them in the entire universe. I can go and send them to someone else over there or someone over there. Why would they know instantaneously that I own them? Because they have the hash of that block in their device. The hash of that block that happened when you receive the packet in that block, that hash is replicated in every block. There's 32 characters replicated. Every device has 32 characters. Every block. So when I send it to somebody that say that a transaction received 6 months ago, I'm able to prove to them that in the 32 characters that they have, the transaction that I have received contributed to the creation of that 32 characters, which cannot be done just like randomly. This requires more computation than the entire planet multiplied by trillion to come up with a fake one like that.
I think it's the only transmission issue, but data, big data.
Yeah.
Which device is keeping or preposition and
continue using that for information, big data. The current internet works very well for big data. This isn't to solve big data. The same way you have a protocol
your
for
own big data, your data.
So here's
Previous
the
data.
big data is not. Oh, you mean the ownership of the big data?
Yeah.
You send me that big data.
Yeah.
The network is only responsible of the hash. Remember what you said? You can send me an entire video, you can send me an entire encyclopedia. The network, the hash, the cryptographic hash, it's still 32 characters. What goes into the chain that everybody is working on, 32 characters. Concat 32. And keep going up all the way in the chain. In the event of, let's say, Bitcoin is 53 levels and Ethereum 64 levels. In whatever blockchain that you want to have it, you can have it 96 levels. You can have whatever levels that you want, but that requires all of those devices to do that work. But it's only hashes. That's all what the network is responsible for.
Amazing. But
Yes.
how different the other blockchain, for example, the performance or speed, how many times?
Well,
차이가 얼마나 날까?
there's every single.
이 아키텍처를 이용한다면
Here's the thing. We have a protocol that can enable blockchains to be built on it. This isn't supposed to be compared with another existing blockchain. But if you build the blockchain on this network protocol, and let's say you have 800 devices globally running. With 800 devices, you only get one transaction per second. That's it.
one?
One. That's it. It sounds inferior, right? But if you have 800,000 devices, you get 1,000 transactions per second. If you have 800 million devices, you'll get 1 million transactions per second, and so on and so forth. The ironic thing in here, that if you were to present to a group of computer scientists anywhere you go on this planet, and you stand up and you tell them, we worked so hard that with 800 devices on this network globally, we only get 1 transaction per second, almost everyone would say, that's it? You should be able to do more. Now start the other way around. Tell them, with 800 million devices, you get to do 1 million transactions per second. They start taking the cans and throwing at you. Bullshit. They don't believe it. It's the same thing. You were saying the exact same thing. It scales linearly. This is true decentralization. That's the benefit. The raison d'etre of the whole decentralization is to get to the efficiency and scalability, not to have additional costs and less scalability. So, yeah.
Finally,
Yeah.
what is your last goal? Your
The last one?
last goal. 목적.
Last purpose? Goal. What is your final
Last
goal?
final.
On a personal level or on a protocol level?
Protocol
On a
level.
Okay.
Technically.
Okay. On the protocol level, my goal is to enhance each and every person's life on this planet by reducing that friction tremendously every single day, every single time they want to manage their own assets or transmit and so on and so forth. And by adding this much value to every person, everywhere, I feel that I've accomplished my goal.
So friction that you are talking about is a friction reduction on energy, electricity, or what sort of conflicts between the programs,
right.
or what is friction?
So if we look back in a world when we used to be only communities of like about 100 people, maybe 150 that you'd see in your life, when you take cash transaction that worked fine. But then in a world where we have 8 billion people that you can transact with, the current system that is centralized, as I've said earlier, require all of those entities to ensure that they're not manipulating the data, they're not being malicious. You need to have many administrators, that they need to be audited and so on and so forth, right? So when you look at all of those, every single time you do any single transaction, they all need to have like the audit trail for up to 7 years to make sure that they comply with their regulators and that there's international laws and all of this stuff. That's a lot of friction. That friction that exists today in the world, the current blockchain promised to solve it, but unfortunately people lost track. They thought that when the ledger was created to mimic the existing ledger model to do this and replace the people by replicating the ledger, everyone started focusing on ledger. The goal was not a ledger. So that ended up replacing friction with a different kind of friction. Wrong. That's not what we want. That ended up replacing with another entity that is called the bank with an entity called miners. And they say, well, the miners are acting in a very decentralized way. The facts don't lie. In 11 years, we barely got to 0.2% global penetration. That cannot be revolutionary. There hasn't been a single revolutionary technology in the world that only made it 0.2%. That's a fact. And the reason why I'm saying this fact is because if you were to see 1,000 other supposedly experts in that industry, they all say it's like, oh, we're only, if we solve the scalability, we will get there. No, that's not true. They solve the scalability by adding more layers and layers. That's wrong. That's not what we're intending on doing. They talk about interoperability layer. That's an oxymoron. It's a peer-to-peer revolution. Interoperability layer. Who pays for it? How does it get monetized? It's another layer. No, that's not the way we do it. We need to bring down, and it has to be maximum decentralization. Otherwise, we don't have anything revolutionary. So, bringing it down that to the level of peer-to-peer, no third layer, you will know immediately that now there's no extraction of wealth. And if there's no extraction of wealth, like any organism in this universe, if you look at the laws of physics, any organism, if it has a lot of friction, moves slowly. You reduce the friction, it's going to move faster. Which means, if we were to get to global prosperity, we will get there a lot faster. We will raise the bar for everybody. We don't really need to look at systems that's going to extract wealth from nations that they can barely support themselves, because we need to provide them with systems that they have all of those current frictions. Instead, the entire planet can benefit from systems that has less friction. The same way the internet came in and said, you don't really need to send a letter by mail that the mailman needs to take it and ship it from here to New York and back. And if you were to have a conversation by letters from here to New York, 150 responses back and forth will take the entire year. You can do that in one day today. So it starts introducing things that they couldn't be possible before. Similarly with this, it's going to enable that movement to be a lot faster. And with the faster movement, you get better economy everywhere. Everyone wins. There's no need to have something that I need to win and you need to lose. Perhaps some people are going to win more than others, of course, because people are going to get it faster. We're going to have control over their ego. People are going to have the ability to understand that this is an opportunity, not a threat. When I speak, people think, oh, it's a threat to the mining industry. Well, maybe the smart miners, which they already got to 9 of them, they see the opportunity, not the threat. That's what smart people do.
So AI technology could do the reduction of friction, or
not in this context. Now, in AI, my passion for AI and the reason why I started focusing on an autonomous, decentralized governance for AI is because I got to the point of, in my mind, I am 100% certain that world of running with the least amount of friction for transactions is attainable, and we are gonna get there. Why? Because I see it, I touch it every day. My certainty about that future is the same certainty that you have that tomorrow the sun is going to rise. So I know that we're getting there. But what worries me, that yes, we got there, great, everybody got prosperous. What are we doing on AI? The current AI is being built with centralized governance as opposed to decentralized. What does that mean? It doesn't have the security models that we just talked about that is essential for reducing that friction. Which means in order to get that, you need to spend a lot of money to ensure that it's being done properly, or you need to trust some systems. So some of the examples that I tell people, if your device is gonna have 8 billion times more than your intelligence in 10 years from now, maybe 20 years, it doesn't change the fact that today you know that your device, or about 5,000 companies that can have control over it. How is that device going to look like in about 10 years or 20 years? Is it going to look like this? Or is it going to be like a pill you swallow? Or embedded in you? Will you take that pill if somebody can control it? And the answer is no. So what are we doing? And that's why it concerns me. And that's why my passion towards getting security on AI should be preventative, should be done now. Because we can correct the world's finance, but we may not be able to correct the world of AI. AI is a one-way stream. Extremely intelligent people like Ben, like yourself, would know that it's a one-way stream. It's not like, oh, we can fix it after the fact. It's either we fix it now or never.
Okay. Okay, thank you. He's got 2 questions.
Sure.
You've answered. 좀 보세요. 예.